All right, hey, good morning, scientists. Today, we're going to think back about our lab yesterday and really talk about what's actually going on with dew point. We recognize that dew point is the amount of air, of water in the air. It's a temperature um, that water will condense, but it really shows us how much water is in the air. Um, and that's really affected um, by the actual amount of water, right? Is the deal. All right, we talked about yesterday, and what does this have to do with weather and air masses and precipitation and all that jazz? All right, so um, this water here condensed, all right, because the temperature of the air reached the dew point, which means that at that point water vapor had to condense, had to turn back from there into a liquid. But the question is why, right? So let's think about this. All right. If you got dew point higher than 65 degrees, it's really muggy. It feels hot. It's our typical summer, right? It feels muggy, and the reason why it feels muggy and sticky and hot, and you just can't cool down, is because we cool down by sweating. However, when you sweat, what's supposed to happen is that sweat evaporates, right? And when it evaporates, it takes heat with you. Unfortunately, if you have a pretty high dew point, is that there just is not that air can hold that warm air can hold so much water that sweat has nowhere to go. The water has nowhere to actually evaporate to. Um, and when the dew point's lower, there's less water in the air, and so that sweat can go a lot quicker into the air because there's just plenty more space for it to hold. Right, and that's kind of how it affects us on a daily basis, on why it's really uncomfortable when it's warm. So think of it this way: so you have air that's a certain amount, and it can only hold this much water. Right, so this much water can fit inside of here, so you can still have water in the air. Right, nothing's going to be condensing. All right, so if we think about it next, then is okay. What if instead of the air being able to hold this much, the temperature drops and it can only hold this much air? Remember, Mr. Gladwell taught you that as air heats up, it can hold more water, and as it cools down, it can't hold as much water. All right, so the amount of water that it can hold held as a gas decreases. Now, at this point, what's going to happen is the amount of water vapor is larger than what can be held as water vapor in the air. And so what happens then? We get dew, we get condensation, right? And that this water used to be a water vapor, but now it's turned back. Now it's turned back into a gas as well. All right, next we're looking at we're going to watch a short video, and then look at a demonstration about why this happens and basically how this happens.
You hear it all the time.
Look at these dew points.
So let's talk about the dew point.
Dew points.
But what does it mean? Dew point is the temperature at which the air needs to cool to reach saturation, aka when dew or water starts to form on surfaces. So let's say the dew point is 65 degrees. During the day, the temperature is 75 degrees. At night, when you go to sleep, the air starts cooling down. When the temperature hits the dew point of 65 degrees, well, that's when the air becomes saturated and dew forms on surfaces. That's why sometimes when you wake up, there are droplets on your car. That's not because it rained, it's because the dew point was reached. In other words, dew point is a good measure of how much moisture is present in the air. The higher the number, the wetter the air is. The lower the number, the drier it is. A dew point of lower than 50 degrees may feel great for you, but it also creates dry conditions not ideal for brush fires if you live on the West Coast. And when your meteorologist says,
Upper 70s. I don't think I've ever seen it higher than 79.
it's likely to feel very muggy, and you may want to stay inside.
Okay, so we know that dew point is a measurement of how much water can be held in the atmosphere. Right? how much water is there in the air, and how much of that water can stay as a water vapor in the air. So how and why does this happen? All right. So we're going to go ahead and experiment with this. All right. So what we see here is some sponges. This represents atmosphere at 80 degrees Celsius, or Fahrenheit, excuse me. This is how much water can be held at 80 degrees Fahrenheit. Right here. And this right here represents how much water can be held, right? If the humidity, this temperature, this is how much water can be held in the atmosphere, all right? And you'll notice it is half, okay? It is half of it, all right? So the amount of, in this situation, we're comparing to these air masses. We're comparing them as if the amount of water isn't changing. So that's kind of the deal here. So what I have here is 60 milliliters of water, and we're going to pour it into this air mass. All right, and there it is. Now, at 80 degrees, what should happen is that if I put this in, you can see that capillary action is so cool. This has to do with hydrogen bonds, but the water can be held by the atmosphere. If I turn it over, let this side do its work, we're going to see all this water, right, is going to be sopped up, right, by this 80 degrees right there. All right, and there's some in here still that we won't be able to get out. If I pour it onto here, right, it's going to soak it right up, right? And we see little to no here. So all of the water in this air mass can stay as water vapor inside that air mass, and they can hang on to it. All right, it can hang on to it. All right. So now we're going to try the same thing, except we're going to try it, all right, with the temperature dropping to 68 degrees. All right. This is the same air mass that had the same amount of water. All right. So we're keeping these things the same. So this is representing that same, all right, that same air mass. All right. I've got 60 milliliters of water. I've already poured out, measured here, and then added into this styrofoam cup. All right. So we're going to have this same, right, same amount of water, right? In fact, it's got a little bit less. You saw some hopped over here. So, all right. So now I'm going to take this air mass, this sponge that represents how much water this air mass can hold, and I'm just going to set it in there. All right. And again, you're going to see the water start to pull, but you'll notice it's not pulling as quickly because it can't hold as much water. All right. I'll go ahead and flip it over. And it is just about saturated here. But we can see all this extra water, all right, that is in here. In fact, our sponge is starting to drop. All right, so at 68 degrees, this is how much water can stay as water vapor. Unfortunately, we have all of this extra water. So what's going to happen to this water? So think about it right now in your head. All right, in this air mass, what's going to happen to all of this water vapor? All right, for it to stay water vapor, it's got to stay inside this sponge. All right, so what do you think is going to happen to all that water? If it can't stay as a gas here in the air mass, all right, that water can't stay as water vapor, then where is that water going to have to go? All right, it's still going to stay really near the air mass. Definitely is still, all right, where's it going to go? Right? Where do you think that's going to go? All right. If you said that it's going to condense and turn into liquid, you're right. That's what's going to happen. And that is what is happening. All right. There's only so much at this temperature. There's only so much water that can be held. All right. And the rest of it here is going to turn into condensation. It's going to become dew. It's going to show up on your roof and on your car and on your grass and on your tree. All right. And if it's cold enough, it'll turn into frost. Frost is the same thing. And if it's like what happened to my garden, unfortunately, it's going to freeze and kill most of my plants. All right. Because it just needs something to hang on to, and then it's going to condense and then freeze if it's below 32 degrees. Just like in a cloud. Remember, in a cloud, you need particles and it's particulates to cling onto. Very same process that is happening. All right, this kind of shows us what is actually happening with dew point and why condensation happens. All right, so that little demonstration helps us understand how different temperatures, how water can just spontaneously like poof into a liquid, into fog, into water vapor. Into liquid that's just on your car or roof or not. So this gets us to, okay, who cares? Okay, so water vapor can only be held as water vapor a matter of temperature, and we call that humidity, and dew point is that temperature at which the water vapor just can't stay at water vapor. Someone's going to turn in. Well, remember, our big idea here is air masses. Weather is all about air masses. Dew point is a measure of how much water vapor is in the air. Our second one is that it's just how we look. What kind of air mass is that, right? How do you know it's an air mass, right? We recognize it by humidity, by the dew point, which is connected to humidity. How much water is in that air mass? It's a big deal, and that goes back to where that air mass comes from. And it also deals with how it affects how an air mass moves. It doesn't mean that it causes it to move, but if there's more water or less water, it's going to change how it interacts with other air masses, right? It's just going to be a cold front. It's a warm front. Why do we have thunderstorms when cold fronts smash into a warm front? And why is it when warm air slides over, you're going to get longer periods of rain? And so dew point and humidity have everything to do with what is the air mass and what happens when two air masses with different dew points and different amounts of humidity, right? What happens when they come together? And that's really our big picture. All right, next you've got a custom review to go over. It's 4 questions long. If you get one wrong, it's going to say incorrect. Look at the picture, watch the video carefully. You could look at it multiple times or watch the video multiple times, all right? Because then it's going to take you back to that original answer, right? And then when it says congratulations, means you've completed it, and go ahead and turn that in and have a fantastic weekend. And take a peek outside and look at the air mass and see if you can't tell. How can you feel the humidity? Has it changed? Has it not changed? All right, from this week or previous weeks as well. All right, we will see you next week.